In order to get a better understanding of the field effect, we're going to consider a two-terminal device called an MOS capacitor. And so this MOS capacitor is sort of the heart of our MOS transistor. And once we have a better understanding of this, it's going to be pretty easy to step to the next stage and add in the other components. So I've got a diagram here, and again, this is sort of the middle of the diagram we saw in the previous video. And so we notice we have, as the name implies, a metal layer, an oxide layer, and a semiconductor layer in that order. And I've got some extra terminology added here that I want to address. So this metal terminal on the top, I've called our gate terminal. And so we'll talk more about why that is in some later videos. And down here at the bottom, we're going to call this our substrate or our body terminal. Typically, people refer to this as our substrate terminal. Something else I have labeled, which is particularly of interest, is our oxide thickness Tox, and we also have an oxide permittivity epsilon subox. And so both of those we're going to see later on when we get into equations are going to play a part in our transistor behavior. So an important thing to keep in mind is that, of course, this oxide is an insulating material. And so because it's an insulating material, if we talk about applying a voltage between our two terminals, ideally that insulator is not going to allow current to flow. So ideally, no current through our oxide. However, we can have an electric field in our oxide, so basically charge on one side can affect what's going on the other side, and so that's what we want to get a closer look at here. So you'll notice that I have this semiconductor labeled as p-type. It can actually be p-type or n-type, but we need to choose one in order to sort of focus on a particular set of behaviors, and then there's sort of a dual if we switch it to an n-type material, for instance. So what we're going to find out is, depending on the voltage that we apply at that gate terminal, we're actually going to end up with three different modes of operation for this MOS capacitor. Three modes of operation. And so in this video, we're going to take a look at the first mode, and in the following video, we're going to take a look at the other two modes. So our first mode is called accumulation. And so our accumulation is going to occur when we have a negative voltage applied at the gate relative to our substrate. So gate is negative with respect to our substrate. Okay, so let's go ahead and copy or rather paste our MOS drawing here. And so again, we said we had p-type material. And so now what we want to do is we want to connect some voltage source between here. And we're going to make it such that the gate is negative. So we have negative up here, positive here, and some voltage V. So of course, making the gate negative means we're going to have some negative charge on our gate up here. And so technically this charge is going to be on sort of the surface side of the metal between our metal and oxide, but let's just ignore that for now and say we have some negative charge on our metal. So what's going to happen is this negative charge on the gate is going to be exerting an attractive force for any positive charges that happen to be down here in our p-type substrate. Now keep in mind, because this is a p-type substrate, we have an abundance of free carrier holes. So free charge carriers, which are holes. And so what we end up seeing is that these holes are going to be moving up to the interface, and we're going to get something that looks like this. And so of course now we have this separation of charge across our oxide, because again the charge isn't flowing through the oxide because that would be a current, and the end result is that we have some electric field. In this case, it's going to be pointing in this direction. So just to sort of recap that, we had a negative charge on our gate. So negative charge on gate, and what that does is that's attracting our majority carrier holes. And once we have enough of those majority carrier holes at that interface, and so we called that our oxide semiconductor interface. So oxide semiconductor interface is going to have an accumulation layer. And so it's an accumulation of those free carrier holes. And so typically this accumulation mode is not going to be one that's particularly useful when we're using this as an MOS transistor. So in the next video, we're going to talk about the other two modes which are of more interest to us.